A logo, National Park Service. Text, Seeking Silver. Investigating Coho Salmon in the Resurrection River. Dan Young, fisheries biologist, Lake Clark National Park.
This project is looking at the Resurrection River Coho Salmon Run. And specifically, we were looking at the spawning migration and then the spawning distribution throughout the watershed. There has been very limited work done in the Resurrection River. We know that juvenile coho are rearing in the headwaters. We also know that there's some limited spawning. In Resurrection Bay itself, there's the state's largest coho salmon fishery. And in the 1970s, the coho salmon fishery was around 20,000 fish. In recent years, in the 2000s, it was over 100,000 fish. And so there was some concern over the sustainability. And then the question is where are these fish coming from? Are they all hatchery origin or are they wild origin? What is the effect on the wild stocks? Because there's absolutely no assessment of wild stocks in the Resurrection Bay area. If you look at a map, the Resurrection River drainage is the largest area within the kind of whole Resurrection Bay area and presumably one of the biggest supporters of that fishery. But one of our primary goals was just to see if we could catch fish. Were they there? What were there? Could we catch them? When and where and how? And we opted to use seine nets and just on foot. We found that if we sampled the eddies along the side of the main channel, we were able to do it safely and kind of pull the seine and then collect the fish that way. And it worked pretty well. So we ended up catching 182 coho throughout from mid-August until kind of mid-October. Because there's a question of whether these are really wild stock or are they strays from the hatchery, we took genetic fin clips from each fish that we captured. And then we also took fin clips from all of the sockeye salmon as well. The preliminary assessment shows that the Resurrection River stock appears to be a distinct stock, but most closely related to the hatchery stock at Bear Lake. Maybe some of the wild stock strayed into the hatchery. The coho, we selected a subset of those to tag. And the purpose of the tagging is so that we could track them to where they were spawning. We could also track their movements, and we could also look at some indication of spawn timing. So once we captured them, we turn the fish over onto their back, and that really calms them down. And we have them in a tagging cradle that's left in the water that allows them to breathe. And then we measure them. And then we take a fin clip and then we insert the tag into the stomach because the fish aren't eating at that time. The tags are about the size of a AA battery. They have a long antenna that kind of trails off after them. And each tag has an individualized pulse, so each fish can be identified. And so we use this technology to just track the fish to where they went. The tracking stations consisted of a solar panel, kind of a tower that held up like a waterproof box, and then inside the box was a tracking receiver that operated 24/7, powered by the solar panel, and it had a 12-volt battery powering that. And then we had 2 antennas generally on each tower that would look at upstream and downstream migration. Every time a fish is within the range of the tower or the antennas, it's recorded into the data logger. So that gives a really good idea of fish passage kind of up the stream. And we had 3 different stations that were operating. Then we would go every week or so and download the data with a computer. And then the second thing, we used a fixed-wing airplane that allowed us to fly the entire river drainage and get kind of a gross estimation of where fish were in the watershed at that time. And we did, I think, 3 or 4 of those surveys. In order to pinpoint where fish were actually spawning, we went out around the prime spawning time, which was in the mid to latter part of October. And using foot surveys, we were able to walk down the stream edge with the antenna. It's a directional antenna, so where you point it tells you where it is, and we were able to track fish to actual spawning aggregations. Sometimes we even were able to see the individual fish, and you could see the antenna sitting out there. Using the tracking stations, the aerial flights, and ground surveys, I feel like we got a pretty good idea of like where they were going, kind of when they were getting there and where they ended up. We ended up tagging 90 fish. Of the fish we tagged, about 75% of them went up into our study area. And of those, 2/3 of those went up into kind of the headwater single channel habitat that had a lot of woody debris, but would be a more stable spawning area. And then the other third were kind of in the lower river that's a more dynamic landscape. In the lower watershed where we were able to do foot surveys and kind of go and track individual fish to their spawning areas, which sometimes we'd only find the remnants of the fish because the bears had eaten everything and the only thing left was a radio tag sitting inside a stomach, and it was just the stomach sitting on the ground. The focus of this project was to look at, were the fish present? If so, when did they come in? And where did they go? And when did they spawn? And I think we answered that pretty well.
Water rushes down the rocky river, and the picture fades to black. Credits appear over the National Park Service logo. Direction, Jim Pfeifenberger. Editing, Monica Bradburn and Annie Langen. Videography, Jim Pfeifenberger and Monica Bradburn. Special thanks Dan Young, Andrew Kirby, James Kramer, Tim Rovinelli, Laura Phillips, Benjamin Pister, and Aaron Kunish.